Binomial distribution is also called as Bernoulli distribution here because it was described by James Bernoulli. Okay, the scientist who has described, or the mathematician who described or discovered this binomial distribution is called as James Bernoulli. So he named as Bernoulli distribution. Okay, so he has already discovered this in 1700, in the year 1700, but it was published in 1713, in the year 1713. But this James Bernoulli has expired on 1705 only. That means after the 8 years of his death, this function, this distribution function has came out. That means even the person who described it or who found it doesn't know that we are going to use this formula as on today. Okay, so that was the case with the binomial distribution. And now binomial distribution, when can a particular problem is said to be followed binomial distribution? See, now there are some conditions over here. The distribution can be used under some conditions. First one is what? The number of trials is finite. The number of trials is finite. Trials means what? Tossing of a coin, throwing of a die, picking up a card, picking up a ball. That should be countable set of values. Now, just now I told you that 10 coins are tossed simultaneously, 50 coins are tossed simultaneously, 100 coins are tossed simultaneously. I can count 10, 20, 50, 30. That means if there are countable set of values, it is the first condition to be followed binomial distribution. Now, second condition is that trials are independent of each other. Trials are independent of each other means what? Uh, See that independent event means what? One experiment is not going to affect the another experiment. Now, just now I told you that I wanted to toss 6 coins simultaneously. That means there are 6 persons are there standing in front of you. Everyone is tossing the coin. Now, let us suppose first person got the answer as tail. Is there any rule that second person has to get head? That means the first person's coin is affecting the second person's coin? No. And second coin is going to be affect the third one? No. That means all the experiments, that means all the trials must be independent of each other. Okay. Now, third point is each trial results in two mutually exclusive and exhaustive events termed as success and failure. Now, that means for any experiment, for any if you are doing any experiment, that experiment should have only two outcomes, not more than two outcomes. What are those two outcomes here? First one, either it might be success or a failure. Just now I told you that. See, while tossing of a coin, sir, you might ask me a question that, sir, you are always stressing on the concept of a coin. That means the binomial distribution only solves the problem of only a coin. No, it's not that. But uh, let us suppose once we are rolling a die, once I wanted to throw a die, so I thought that I have to get an even number. I have to get an even number. But what happened? I got a number 5. That means I'm a succeeded or failure. That means any experiment which can result in only two outcomes, either it can be success or a failure. I am writing an examination. I have only two chances to come out with. Either I'll pass the examination or fail the examination. Or let us take one more example. How many genders we have? Male, female. That means we should have only two outcomes of any experiment. That means if a lady is going to give birth for a baby, and what is the probability that the baby is a boy or a girl? It is 50-50 chances. That means they have only two chances to come out with. Okay, male, female. There is no other something over here. What type of color you wanted to choose? See, because colors are n number of different kind of colors are there, so we cannot choose one out of many. So if you wanted to select any particular color, that particular color will be your success, and the remaining colors will be your failure. Okay, so once again, when there is an experiment, let us suppose one fellow who doesn't have any work, he wanted to throw the die or tossing of a coin, and these experiments are countable number of times. He wanted to throw for 100 times or 200 times, let us suppose. It is countable. Now, trials are are independent of each other. Yes, of course. First experiment is not going to affect the second one, and second one is not being affected by the first one. Now, third one is each trial must be two outcomes only. Either, and those should be mutually exclusive. Mutually exclusive means if one is happening, that will stop the another one. That means if tail is happening, it will stop the happening of head. So, and those outcomes are termed as always a success and a failure. If you want whatever you are expecting, if you get the same result, that is called as a success. If not, that is a failure. Now, next, last condition is that small p, the probability of success is constant for each trial. That means success is denoted by small p, and that p should be a constant value. Constant means what? It should be a numerical value 1, 2, 3, 4, 5, or a fraction value 1 by 2, 2 by 3, 4 by 5, something value. It should be a numerical constant value. It should not be a variable. I cannot say that p is equal to 2x again. Okay. Now, then q equal to 1 minus 3 is the probability of failure in any trial. That means at the same time, wherever you have a success, which is followed by the failure also. Just now I've shown you an example that, see here, tossing of a coin, I have only two outcomes, that is tail and head. If I feel that head is my success, then tail is my failure. Now, see in one experiment, both tail and head are there. That means I need to consider both my failure as well as my success also. So now, probability of success is denoted by small p, and probability of failure is denoted by small q. Okay, these are the four conditions that any problem has to come across to follow the binomial distribution. If these conditions are satisfied, if these conditions are satisfied, then that problem belongs to the binomial distribution. Now, let us come for the formula of the binomial distribution. What is the formula? Formula is nothing but distribution function in statistical methods, in probability especially. Okay. So now see this. P of x is equal to small x, that is equal to, our formula is ncx into p power x into q power n minus x, where x is equal to 0 to n and q equal to 1 minus p. Just now we are seeing the formula, like always q is equal to 1 minus p, that keep in mind. Now, see, this is the general formula for us. Ncx into p power x into q power n minus x. Now, n is what? n is my n is my number of trials. N is my number. I'll explain this definition. N is my number of trials. Let's suppose there are 10 coins are tossed, then n will be 10. If 100 coins are tossed, then n will be 100. If 5 coins are tossed, n will be 5. And x, what is x called as? X is called as number of successes. Number of successes. Now, see, let us suppose 3 coins are tossed now. 3 coins are tossed. Then what is the value of n here? It is 3. What is the values of possible values of x? See, always x is ranging from 0 to n. That n will be decided based on the problem. Now, if I wanted to take the 3 coins, now what is my n value here? That means x can take what are the values when I'm tossing 3 coins. X can be 0, 1, 2, 3. Why? Because I can have maximum number of successes where number of coins are there. Okay, I think you people got the point. Number of successes cannot be greater than the number of coins. When 3 coins are tossed, I may have a situation that I don't get any success. So that is 0. I may have 1 success. I may have 2 successes. I may have 3 successes. Let us suppose I am having one more coin also. One more coin also. Then what does this outcome becomes? It becomes 16. Yes or no? 2 power 4 is 16. Then my number of successes will be starting from again 0, 1, 2, 3, and it will end up at 4. Number of coins should be equal to the maximum number of successes. Okay, since it is n, this also ended at n only. Now, if this is 4, x is ranging from 0 to 4 only. Okay, now p power x. See, once we know the value of x is nothing but number of successes, and p is nothing but probability of success, q is probability of failure. Probability of success means what? I just told you that what is the probability of getting a headman, as we know that it is 1 by 2, right? So p is 1 by 2. Immediately q will become what? Again 1 by 2. 1 minus 1 by 2 is 1 by 2. Simply substituting the values onto that, we can find out whatever the question they are asking us to find out. So this is the generalized expression what we use to find out the solution of the given problem. Okay. Now, see, now for this there is an explanation on the top. X denotes the number of success in n trials. X denotes number of successes. I just now I told you this X represents number of successes in n trials. N trials. Okay, satisfying the conditions. Then what are the conditions? Just now I told you there are 4 conditions. It must be finite, they must be independent of each other, they must be two outcomes, success and failure, and always the probability of success and failure must be a constant value. So if these conditions are satisfied, then x is a random variable which can take the values, see here, 0 1 2 up to so on n, 0 to n. Why? Since in n trials we may have no success, no success. Just now I told you, na, in 3 trials I may have no success. That means I don't have any tail over here, so that is not a success. Sometimes I don't have success, I may have 1 success, I may have 2 success, and up to so on I can have maximum n successes. So with this basic condition only we have got this formula to be found out. Okay, this is the formula of, if even in your internals also you might get a question that what is the formula of binomial distribution, then you need to write that nc x into p power x into q power n minus x, where x is equal to 0 to n. This notation is also mandated to be written, that x is always ranging from 0 to n. Okay, so in binomial distribution, basing on this formula, there are some properties are there. Properties are nothing but the characteristics. What do we say? Like mean, variance, and standard deviation. Mean is always denoted by mu. From now onwards, see, usually we say that x bar, right? That is for sample of observations, we take it as x bar. For population, we always say that mean is equal to, it is denoted by mu value. And this here, mu is equal to n into p, where n is number of trials, p is probability of success. Let us suppose there are 4 coins are tossed, 4 coins are tossed, and the probability success is 1 by 2. Then mean is how much? 4 into 1 by 2. It is equal to 2. That is mean. Now next, variance. Variance is equal to n into p into q. N is nothing but 4, p is 1 by 2. If p is equal to 1 by 2, q also will be equal to 1 by 2. So now 4 into 1 by 2 into 1 by 2, what is the value of variance? It is 1. Now standard deviation is how much? Square root of 1 is also equal to 1. So that's how we try to find out the answers of each and every given problem. So, okay. And keep this note point in your mind that in binomial distribution, mean is always greater than variance. See, just now I told you that mean of the given just now problem, n is equal to 4, p is equal to 1 by 2. Mean is how much? It is 2. Yes or no? 4 into 1 by 2 becomes 2. And variance, what is the answer of the variance? We got as answer as 1. That means mean is 2, variance is 1. So now in binomial distribution, mean is greater than variance or not? Of course, right? Mean is greater than variance all the time in binomial distribution. Okay, this point has to be one of the most important point that which you have to be remembered.